So in this video, we'll talk about the very general form of line. And what I'm talking about is the form like so. So this is ax plus by plus c equals 0. This is the most general form of line. And if you go on to study higher forms of curves like a parabola or a hyperbola or something like that, or basically conic sections like a circle or something like that, you will encounter that you end up getting higher and higher, more complex equations, which involve terms like x squared plus by squared plus cxy plus probably dx square y or something like that. So things can get really complex, and even that equal to 0, you get a particular curve. Now it's been studied, and people have found out that if you want to represent a line, first of all, you get rid of all the cross terms. That means x and y cannot be present in a term. You cannot have a xy times something term. Once you eliminate all the possibilities, you also eliminate the possibility of getting a squared term like x squared or y squared. You do that, and there are certain other rules that tell you that you can only have a line which has this form. Now, one way to see this, let me just get rid of this because this does not pertain to what we're actually studying. So if we actually check our equations of line, like so, y equals mx plus c, you can easily realize that minus m times x plus y, 1 times y minus c equals 0, which is of the form ax plus by plus c. That means even the line that the equations of the line that we ended up studying before we knew about this form, even those kind of forms still lie within this category of expressing the equation of line. In those cases, a is minus m, b is 1, and c is, well, minus c. If you call this a small c and you call this a capital C, that is how you equate. You get the values of the constants, capital A, capital B, and capital C. So even in this kind of case, this actually falls under this kind of a category, the more general way of expressing a line. Now, say we are just given a line of this form, something like 6x minus 2y plus 10 equals 0. We can have a line of this form. It's not very easy to see at this point what the slope of the line is, what the y-intercept is, or for example, what the x-intercept is. So you have these three quantities that you don't immediately see. Whereas in cases of expressing a line in the manner of y equals mx plus c, you definitely know what the slope is. If you know y is expressed as 6x plus 10, well, the slope is 6 and the y-intercept is 10. You can also graph the line in that manner, such that this is 10, and you choose theta to be a value such that tangent of theta equals 6. So you can find theta as arctan of 6, something like that. Basically, you get an angle and you get where it passes through, where the line cuts the y-axis. So you can define a line very easily, and you can actually graph it quite easily if you know the form. If you have the line originally present in this form. But if you have the line present in this form, it gets rather tough. So in this video, what we'll talk about is how to understand and visualize a line which is present in this kind of form. One very clever way to do that is to actually turn the equation, say this equation, in the form of this. That is, get the coefficient of y to be 1 and work your way around it. And if you see that this form of an equation matches this form, then you definitely know what the new coefficients of x and y are, and you can manipulate that to get the information. I'll do that right now. Like so. Alright, so let me change my color again. How about a good red? So we want our line to be expressed as y equals mx plus c, right? The important point here is that the coefficient of y is 1. So let us make the coefficient of y in this equation to be 1. And one way to do that is divide the whole equation by b. So once you do that, you get a by b times x plus, well, b by b times y is c by b times nothing, and you get that to be 0 because 0 by b is still 0. You cancel that out, you get 1. You take all the other terms on the right-hand side of the equality, leave y as the subject of the equation, very much like what we have here. We get y equals minus a by b x and minus c by b. So in such a case, we have reduced our equation originally from here to this, and you can very easily see what the slope of the line is. This quantity here gives you the slope, and this quantity here gives you the y-intercept. So if we were to plot this line on the graph, we would have a y-intercept of minus c over b, and the slope to be minus a over b. And this would be the equation ax plus by plus c equals 0. So that is how we reduce the problem to a familiar form. The other way to do this is also rather interesting, and I should cover that as well. So let's clear it up again, entirely this time, and let us write our equation again once again. We started with ax plus by plus c equal to 0. So we need to plot this equation, and if you want to plot an equation that's given to you, or you want to plot the line for that, same thing, you need to find 2 points through which this line passes. If you have those 2 points, you just connect them and you get the entire line. So what we can do here is we can choose 2 rather special points. So like with every other line, it has to pass through the y-axis and has to pass through the x-axis at some point. The point can occur anywhere between the range of minus infinity to plus infinity. That means it could be anywhere on the x-axis, or it could be anywhere on the y-axis. So basically, we're assuming that the line passes through x and y. It could be something like so. So what we are choosing to do at this point is suppose this is the line that represents this equation, ax plus by plus c equals 0. We have 2 special points, so and so. What we know about these 2 points is that if this distance is the x-intercept, and this distance the y-intercept, then the points A and, no, I can't call them A and B, P and Q would take the form, say for Q, that form would be something like x sub 0, 0. Why? Because the point lies on the x-axis, so the y component has to be 0. And for P, the same thing would take the form 0, y naught, or y sub 0. Why? Because the x component here is 0. So once we have that clarified, we can proceed. What we can do is we can try to evaluate what x naught and y naught would be with respect to this equation. So if you want to solve for P, we simply put x to be 0, because here x is 0 and y equals y naught. And we put y equals y naught. So that makes a times 0 plus b times y naught plus c equal to 0. Or, you can simplify that, you can get y naught equals minus c by b. Simple as that. So you already know what this height is, which is minus c by b. And if you recall, this is the same thing that we got when we reduced this equation to the form of y equals mx plus c. Well, if you can see that, that'd be great. So what we divided everything by b, and we took everything on the opposite sides of our variable y, and we got the negative sign and b in the denominator. So that works with what we actually ended up doing in the previous case. Similarly, we can solve for q. Let me change the color. Have it purple. We can solve for q like so. And in the case of q, we put x to be x naught, and we put y to be 0, because y here is 0 and x here is x naught. Remember, this equation is valid for all the points. What we're choosing to do is we're choosing a specific point which lies on the x-axis. So the y component of that point has to be 0. We do the same thing, a times x sub 0 plus b times 0 plus c equals 0. This term gets cancelled out, and x naught comes out to be minus c over a. So quite a similar form as what we got for y naught. So in totality, what we have found is that if this is our equation, right here, and if this is our line, then this height here equals the value of y naught minus c over b, and this height, this distance rather, here turns out to be minus c over a. If do we recall what the slope of this line was? And turns out, well, the slope of the line was, let me see, b, we divide everything by b, we take it there. Well, that was minus a by b, turns out to be the slope. I hope I'm right at this one. Divided by b, take it there. Right, so this is the slope, these are the y-intercept, and this is the x-intercept, simple as that. So, is there any other way to get the value of the slope? Well, one way was to compare it with this equation, which we've already done, and that's how I wrote this answer. But the other way also is to kind of use the other rules that we already know. One of the rules is that if we know 2 points on the line, which we do, this point is minus c by a, comma 0, and this point is 0, comma minus c over b, then we know what the slope of the line is. Recalling that the slope of a line segment expressed by 2 points is the difference in the y-coordinates divided by the difference in the x-coordinates taken in the same order. What we can do here is we can subtract the y and the x components and get this. So y2, let's call this to be the second coordinates, and let's call this to be the first coordinates. So y2 minus y0 is minus c by b minus, here the y component is 0, so minus 0. In the denominator, we get, well, x2, which is 0 here, minus c over a. We can simplify that to get minus c by b divided by c over a. This turns out to be minus c by b multiplied by a over c. We can cancel that out and we get, once again, minus a by b. Same as what we got when we tried to express the line here and compare the values of m. So I hope that this video made sense and allowed you to work with a more daunting form of an equation of the line ax plus by plus c equals 0 rather than more familiar one, y equals mx plus c.